Let us now see a first case on the Newton-Gregory's method. So you've been told table 1 represents a cubic polynomial f of x. So it means from that statement, the word cubic will imply that when you will be forming an interpolation polynomial, they want you to reach where the highest power of x is what? Is 3, isn't it? Meaning you move up to where you have delta cubed, isn't it? Are we together? Yes. Then it means you will have found that interpolation polynomial. Then you'll be told to use Newton-Gregory forward difference interpolation formula to determine the value of f of 0.5. So if you are told to determine the value of f of 0.5, you don't need to form the interpolation polynomial, because if I look here clearly, I can see 0.5 is between -1 and it's between 0 and so it is between 0 and 1. Meaning 0.5 is in the table. So if it is in the table, we don't need even the interpolation polynomial, isn't it? Are we seeing that? We don't even need the interpolation polynomial, we can get it directly. But in this case, we will just get the interpolation polynomial for the sake of explaining the concept, isn't it? Are we together? Yes, so the first thing, as usual, for us to use the Newton-Gregory forward difference interpolation, the first thing we have to construct a finite difference table. You have to construct a finite difference table. So before you start constructing a finite difference table, you count the number of values, isn't it? How many values do we have? 1, 2, 3, 4, 5, 6 values in 6 columns, isn't it? So 6 you multiply by 2, meaning you have 12 rows. You're going to make 12. Only the values you count. 1, 2, 3, 4, 5, 6. 6 times 2, 12 rows. Because the last row will only have 1 row, and the first row will now take the title, okay? So let us construct 12 rows. Come and construct 12 rows. Form a table of 12 rows. That is row 1, row 2, row 3, row 4, row 5, row 6, row 7, row 8, row 9, row 10, row 11, row 12. So, when you be told it is a cubic, polynomial cubic means we are going to reach delta cube, isn't it? Are we together? You see the polynomial, maybe we can go on, but they are talking about cubic, meaning delta cube is our point of focus. So, the first 2 columns is for the values we've been given. So, let us start. So we have the x values and the f values. Because this one is direct, we are using the forward difference interpolation, so we just go with f naught direct, isn't it? Are we together? Yes. So, key in the x values. The first x value is -1. You skip 1 space, then 0. You skip 1 space, then 1. You skip 1 space, then 2. You skip a row, then 3. You skip a row, then 4. Meaning the last value of x is only having 1 row only, isn't it? Are we together? Yes. Then you put the f naught. When x is -1, we have -4. When x is 0, we have -1. When x is 1, we have -2. When x is 2, we have -1. When x is 3, we have 8. When x is 4, we have 31. Are we together? So we now start finding the differences, isn't it? Are we together? The finite differences. So the difference is something is always denoted with the delta for the difference, isn't it? So the first delta there, as usual, how do you get the difference in something? It is the second value minus the first value, or final minus initial, isn't it? So the difference between these two values, because this difference you can see they are the difference of the f's, isn't it? These are the f values. Are we together? So the first difference here you have, the difference is noted by delta. So negative 1 and negative 4, it will be second minus first. Negative 1 minus negative 4, you use the calculator, isn't it? Negative 1 minus negative 4 is 3. You get that. The next difference is here, second minus first. Negative 2 minus negative 1, negative 1. Then the next difference is here, negative 1 minus negative 2. You get? Positive 1, isn't it? Then the next difference is the next two values here of f naught. 8 minus negative 1. I hope you're using a calculator. The next difference is here, 31 minus 8. 20? 23. We are done with that. We go to the next differences, delta squared, isn't it? So after we found delta, we are now in delta squared. And so start. The next difference is between here, isn't it? Negative 1 minus 3, second minus first. Negative 1 minus 3, negative 4. You write in the middle there, isn't it? You move, the next difference is here. Negative 1 minus negative 1. 1 minus negative 1, I mean. You have 2. Good. Then here, the difference is here. 9 minus 1, 8. The next difference is here. 23 minus 9, 14. Are we together? Are we together? You move to the next column. This is delta squared. We are now in delta cube. Are we together? See, the next difference is here. 2 minus negative 4. Yeah? 6. I hope you're using a calculator. The next difference between these two values, second minus first. 8 minus 2, 6. The next difference is here. 14 minus 8, 6. You see, there's no need of going to delta to power 4 because we were told it is a cubic. We were told it is a cubic, meaning we want to reach where we have power 3. Are we together? So it means at this point when we have power 3, we have already gotten a cube, isn't it? Cubic. So it means we don't need the other columns we don't need. So the columns we don't need, there's no need of constructing in a finite difference table. Is that understood? Because the question is very clear that we need a cubic polynomial. Are we together? So, after getting this, the next thing we need to find is that value of b, because we want to construct the polynomial, isn't it? You want to evaluate at a point when x, because this is supposed to be f of x. So when you are told f of 0.5, it implies at a point when x is equal to 0.5, isn't it? Are we together? So where is x is equal to 0.5? Because these are the x values. Are we together? So 0.5 is between 0 and 1, meaning we want to evaluate it at that point. Are we together? We want to evaluate it because 0.5 is between here. It is between 0 and 1. It is an x value because it is f of x, meaning x is 0.5. X here is 0, x here 1, so it is between here. So if we just want to form an interpolation polynomial, we can say if this value which is here to be x0 and the value at the end here to be x1, meaning the value in the middle we are looking here to be x. Are you seeing that? So how do we get b? That was the point. Getting b, we say this what? It is the x minus the x0 minus the initial, isn't it? So it is the x we are looking for. It is x minus x0 over the h. H is the whole height of the whole interval, isn't it? So the whole of this interval, we have it. It is from x0 to x1, meaning this whole interval. This whole interval is the h. But now, what we are looking for is x is here, meaning the interval for x is that. So what we are looking for is this smaller interval over this larger interval. And this smaller interval here, you can see it is x minus x0. Then the larger interval here, you can see x1 minus x0, which is, are we together? Yes. So this means what do we have? X minus x0 over x1 minus x0. Such kind of cases you'll also be seeing in the Lagrange's interpolation polynomials. So if you look at that, this small interval here from the value we are evaluating is x minus x naught, the numerator, isn't it? Then the whole interval is x1 minus x naught, which is the edge. So can we now substitute those values? What is x minus x naught? See, x naught is 0. So it is now x minus 0. Are we together? X minus x naught is x minus, then x1 minus x naught, x1 is 1 and x naught is 0. So 1 minus 0, you get it to be 1, meaning our edge is 1, isn't it? Are we together? Yes, because it is that edge which is x1 minus x naught. And x1 is 1, x naught is 0. So edge is 1. So it means, what is p? P is x minus 0 over 1. Is that point well explained? Is it well explained? So from here we found x minus x naught is x minus 0 is x over h is the whole interval 1 minus 0. We found is 1. So x minus 1 is just x. Are we together? So we found p is equals to x. That is what is important there. P is equals to x. After getting p, the next thing we need to get, remember our x is here, you must put a line where you are evaluating. Our x value is here. So we put a line, a dotted line, we say we are evaluating x at this interval, x and x naught. Then you move. What do they want? They want a forward. So forward means you are moving forward. And if you look at the x values, negative 1, 0, 1, 2, meaning moving forward is like moving in that direction, isn't it? So you are moving forward. And if you look at this table, moving forward is from negative 1, 0, 1, meaning moving forward is moving downwards, isn't it? And the point we are evaluating here. So it means for us to move forward, the next difference value is negative 1. So at negative 1, moving forward will be in that direction. Because negative 1 to 6. Meaning, if you move the other direction, you will be going backward to the smaller x values. Are we together? Are we together there? Yes. Yeah, so you can see how moving forward is from this smaller x value towards the other direction. And in the finite difference table, that value is like downward. So here, it means when you are here, the next difference value is negative 1. From negative 1, the next difference value forward is 2. The next difference value forward is 6. So it means it is like the line is moving like that, isn't it? Are we together? Yes. Forward, if you are at negative 1 here, forward means the next value which is forward is this. Then after this, between negative 1 and 2, which one is forward? See 2. Then after 2, the next value 2 is moving like that. We have 6 over 6, meaning the one which is forward is that. So the line is moving downwards for the forward difference formula. Are we together? So we've already placed the line where we want to form that interpolation polynomial for the Newton-Gregory method, isn't it? For the difference method. So after getting P, the next step is to get the binomial series, isn't it? So the binomial series we've seen, when you have 1 plus x raised to power n, the first 2 terms is 1 plus nx, isn't it? Then you move to the third term. How are we doing it? When you have n factorial, that means it is n into n minus 1 into n minus 2 into n minus 3 factorial in that order. So the first term, if you are expanding 1 plus x raised to power n, the first term is 0 factorial. 0 factorial means no term in the numerator and your x is raised to power 0, isn't it? Then the next one plus, after 0 factorial, 1 factorial. 1 factorial means there's only one term in the numerator. And then your x is raised to power that one. Then plus, after 1 factorial, we have 2 factorial. 2 factorial means there are 2 terms in the numerator. 2 terms reach here, n and n minus 1. N by n minus 1, then our x is raised to power that 2. Then the next one, it means we have 3 factorial. And 3 factorial means we have 3 terms in the numerator. 3 terms is 1, 2, 3. 3 terms is reaching there, n minus 1, n minus 2. Then your x is raised to power that 3. That was just a methodology. That was just a set of procedure of mastering a formula. And we actually saw that was a Maclaurin series expansion of the binomial, isn't it? Are we together? So you can see 0 factorial is 1, x raised to power 0 is 1. So 1, the whole of that term is 1, isn't it? And here you can see 1 factorial is 1, x raised to power 1 is x. So the whole of that term is n times x, is nx. So it means the first 2 times that we move to the third term here is where we now have the 2 factorial, then 2 terms in the numerator, n into n minus 1, then our x is raised to power that 2, isn't it? Then the next term we have the 3 factorial, and the 3 factorial means 3 times in the numerator, n into n minus 1 into n minus 2, then our x is raised to power that 3. Are we together? The reason why we are reaching, because we can expand it up to eternity, up to the value of n. But the reason why we are reaching x to power 3, because we've been told it is a cubic polynomial. Are we together? Remember, this one has nothing to do with this x in our equation. This one is just what we want to use to get that p, isn't it? Are we together? So for us to use this, what does it imply? It means where there is, we need 1 plus delta raised to power p, isn't it? See, that is what we need. So 1 plus delta raised to power p, meaning where there is x, you put what? Where there is x, you put delta. So here you see, with me at this where there is x, I put delta. 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 So I have 1 plus delta raised to power n. But now we want power p. Meaning where there is n, you put p. Where there is n, you put p. Anywhere you see n, you put p. Anywhere you see n, you put p. Where there is n is p. Where there is n, you put p. So have you seen? Because with me I can lab with you, it means you'll be writing the 2 equations to see how that binomial, this is resulting from binomial, isn't it? So I've now found the formula for 1 plus delta raised to power p, that binomial expansion, isn't it? Are we together? Now, I want to make it a forward difference formula, meaning for forward we are using f naught, isn't it? So if this was f naught, these differences were for f naught, for the forward. Those differences were for the f naught. So how do I bring the f naught here? Meaning I multiply both sides of the equation by f naught. Are we together? For me to get the f naught. So if I multiply all through by f naught, it means here we'll have f naught. This 1 times f naught is f naught. Then I will have f naught. Then I will have delta squared f naught. Then I will have delta cube f. Are you seeing the way I'm constructing the formula stepwise? Are you seeing? You cannot just come to it directly finally. You see, this is now the final product. And you see now we've come about the final product, isn't it? It is a stepwise process, isn't it? We start with that binomial series. After that, we substitute our x with the delta. After that, we substitute our n with the p. Then after that, we multiply all through by f naught for the forward difference formula, isn't it? Are we together? Are we together? Good. So after doing this, it means you now have the Newton-Gregory forward difference interpolation polynomial. So it means the whole of this binomial expansion is our f of the polynomial. It is the polynomial you've expanded, meaning f of x is what is equivalent to this, isn't it? Are we together? Because you can see our p is in terms of, are we together? Meaning this is the expansion of the polynomial, the cubic polynomial f of x, because p, we said is in terms of x. Are we together? So these are x's, these p's we found in terms of x, meaning this is the expansion of a polynomial f of x. So it is like saying f of x was the 1 plus delta raised to power p f naught. And when we've expanded that f of x we found, it is what? It is f naught plus p delta f naught, then plus p minus 1 delta f naught over 2 factorial, if you leave delta there, then plus p into p minus 2 over then delta f naught, isn't it? So we are reaching delta cube because we were told it is a cubic polynomial. Are we together there? Because it is a cubic polynomial. So after doing that, meaning what we are doing is now just substituting the values, isn't it? We are substituting the values. So you see, it is easier to get this interpolation polynomial when you are evaluating at a point when x naught is 0. Make it simpler, isn't it? When x naught is 0, it is very easy to get that interpolation Gregory and the Newton-Gregory interpolation polynomial. Are we together? So anytime you want to get the interpolation polynomial, it is good to see, do I have a point when x naught will be 0, it will be easier. Are we together? Good. So can we now do the substitution? What is f naught from where your line is? So your x you are evaluating here. So your line is there. What is your f naught at that on top of that line? Negative. So it means this is -1, isn't it? Are we together?
Yes.
F naught is negative. Then plus. What is P? Your P is P you found there. And you found it is x. Are we together? Your P is, so you put x where P is. Then what is your definite difference? Delta F naught. Your line is what is guiding you. Delta F naught is here. So you move up to where your line is reaching. It is below the line, on top of the line is negative. -1. So it means this is times -1. I'm done there, isn't it? Then plus, what is your P? So this is x into x minus 1, isn't it? Are we together? X into x minus over 2 factorial, then delta squared f naught. So delta squared f naught, you move until you get the value which is on top of that, your line. Your line is here, isn't it? So which value do we have? 2, isn't it? Are we together? So that is 2. Then you move plus, your P is x, isn't it? So it is x into x minus over. Then what is your delta cube f naught? What do we have in that line? 6, isn't it? You have 6. So it is times 6. So what do? So we simplify. We simplify the formula. So we have f of x is equals to -1. Then you move x times -1, negative x, then 2 divided by 2 factorial, 1. So you remain with plus x into x minus. So that is what you remain with, isn't it? Because this 2 factorial is 2 divided by 2 goes, you remain with x into that. Then the next one, 6 divided by 3 factorial, 1. So see, this is what you now remain with. Are we together? You remain with x into x minus 1 into x minus 2. So you simplified, and you can now see f of x is a cubic polynomial as stated, because the x power of x is power 3. You can see x times x times x, meaning the x power of x you can get is x power 3 for a cubic polynomial. Are we together? So it means once you've constructed this polynomial, you can now use it to evaluate anything. Meaning the importance of having this polynomial can evaluate anything. You can even get f of 10, and you can see 10 is not among the values of x. Are you seeing the reason why we're saying when you have the polynomial, you can evaluate any point? See here, x values we only have from -1 to 4. But here you'll be told to evaluate f when x is 10. So you can see when x is 10, it's not in the table. Senor? But you can get it because you have the interpolation polynomial. Senor? Are we together? Are we together? Good. So we were not told to find f of 10. We were told to get f of 0.5. So f of 0.5 means where there is x, you put 0.5. So if you put 0.5 where there is x, what do you get in the calculator? What you do in the calculator, you say this is -1. Where there is x, you put answer. -1 minus answer plus answer into answer minus 1. Where there is x, you put answer. Then plus answer into answer minus 1 into answer minus 2. Meaning x is your answer, isn't it? See, that is how to evaluate a value in the calculator. So you let your x 0.5 is equals to 0.5. So the moment you say 0.5 is equals to 0.5 in the calculator, meaning 0.5 is now answer, isn't it? So it means where there is x, we're now substituting with the answer in the calculator. So in the calculator, you put -1 into -1 minus answer plus answer into answer minus 1 plus answer into answer minus 1 into answer minus 2 to make work easier. Are we together? If you don't like that, you can just put your 0.5 where x is. You still get the same thing. What do we have here? Here I have -1.375. Anybody with a different answer? He has done exactly that. Good. Good. Then you can also confirm by putting again 0.5 is equals to 0.5. Then you replay the calculator to confirm. It's the same thing. -1.375. 375. And you found f of 0.5 using the forward difference formula. Are we together? You found f of 0.5 using the forward difference formula.